All right. So the last thing, and probably the most difficult part of this continuity thing, is something called the Intermediate Value Theorem. And I shot this video and I did this example so that you could really rewatch it over and over again. But I'm going to try to explain it to you real quick. So in this class, we sort of have two big theorems. Intermediate value theorem is the first one, and like the mean value theorem. These are two theorems where like we kind of have proof style questions. And how does the theorem work? They kind of give you two conditions. And then if both of these conditions hold, that means that the conclusion is true. So those two conditions are, you need your function f to be continuous on the closed interval from a to b. So if you look at this picture, I can draw my graph without lifting my pen off the paper. So that's the continuity condition is satisfied. Then the second condition is, if you take a look at the function value at those two endpoints, so here's the function value at A, and here's the function value at B. If n is going to be some number that's in between these two guys. So in this case, our n is kind of in between f of A and f of B. So if you have a continuous function and n is between these two guys, what's the conclusion of the theorem? The conclusion of the theorem is that there's some point C in the middle where your function value will actually attain that number that's in between the two y values, f of A and f of B. Okay. So I can give you a real life example of this intermediate value theorem. So let me show you on a different page here. If I was to draw a picture for you, this is Colorado. And this street over here is called Bonnie. And PCC is over here. Do you guys know what's over here? Anyone have any feeling as to what's over here?
Chick-fil-A.
It's Chick-fil-A. So I just realized a lot of you guys are freshmen that have never been on campus, so you don't know what I'm talking about. But if you do know what I'm talking about, let's say you're here at PCC. This would have been more comfortable, more powerful if we were in person. And you wanted to go to Chick-fil-A. There is no way we can go from here to here in a continuous fashion without crossing Bonnie. So we're basically saying Bonnie is like the letter N. And over here, this is U, this is f of A. And over here, this is f of B. And if we have a continuous function, I need to cross Bonnie at some point. And that crossing point is what we call C. So this isn't the best graph, but this kind of captures the real life idea. The real life idea is if I'm here, there is no way I can get to f of B without crossing Bonnie. So at some point you have to cross Bonnie. And that point where you cross Bonnie, that's what they call C. So if I go back to my class notes over here, here's f of A, here's f of B. If this guy is going to be continuous, I have to cross N at some point. And that X location where I cross N, that's C. Okay. So how do these problems work? Well, these problems work by, you have some function, and then you have to have some number N. And in this case, when they say it has a 0, we're saying f of some number is going to be equal to 0. So our N is going to be 0 in this case. Now, in this example, I had to supply the two endpoints A and B. So I just made up these two endpoints. And when I look at the graph, you can see this is a continuous graph. My n is going to be the y value of 0. And when I come here and I go up to here, I have to cross y equal to 0 at some point. Okay. So the first thing I do is I argue that it's a continuous function. And it's a continuous function because it's a trig function. We saw up above over here, all trig functions are continuous on their domains. So I've satisfied the first condition, which is that it's continuous. The second condition says I need my f of a and my f of b to bracket n. Now, in our case, our n is 0. So if I plug in a negative pi over 6, I get a negative number. If I plug in a pi over 6, I get a positive number. 0 is between these two y values. Once both conditions are satisfied, that means we can use the intermediate value theorem. So the conclusion is true. So this says that by the intermediate value theorem, there's some point in between a and b, so that when I evaluate my function at that point, I'm going to get the n value. And this shows that we have a 0. So I think we should look at this classwork together and see how we're going to unpack this. And normally I would let you struggle for this for a little while, but we only have 10 minutes left. Oh shoot, class ended. I forgot, this class ends at 12, not 12:15. If you got to go, you can go. I'm going to keep going and you can just watch the video later. So have a great weekend, everyone. And make sure you watch the 2.1 and 2.2 videos before class, okay? Don't feel bad if you got to go. Just take off.
All right, thank you, Professor.
Take care. For the rest of you, if you want to stick around, you can. I'm going to finish this off. I'll just probably pause while the people leave because it keeps making all that sound. All right. So we do want to do the intermediate value theorem. We need to pick out a few things. We need to pick out our f of x. We need to pick out an n. We need to pick out an a. We need to pick out a b. So in this particular question, because we're working on this interval from 0 to 2, I think that this tells us that our a should be 0 and our b should be 2. Okay. In this particular case, since I want to show that this guy is equal to 3, I think we should take the left-hand side to be our function. So that'll be 3x to the 5th minus 4x squared. And then I think we should take the right side to be the n, which is 3. Now I need to show that the two conditions of the mean value theorem hold. So we're going to have the first condition is show that f of x is continuous on the interval from 0 to 2. And that's true because f is a polynomial, so it's continuous everywhere. Okay. The second thing I need to show is I need to show n is between f of a and f of b. So my f of a is equal to what? That's going to be equal to 3 times 2 to the 5th power minus 4 times 2 squared. We need to calculate what that is. We need to calculate what f of b is. F of b is going to be equal to, oh shoot, that's f of b. F of b should be equal to f of 2. F of a is equal to f of 0. Okay. That's going to be 3 times 0 squared minus 4 times 0 squared. 0 to the 5th, sorry, minus 4 times 0 squared. That's equal to 0. When I calculate the f of 2, that's going to be 3 times 32 minus 4 times 4 is 16. This is going to be a, what is that? That's going to be 96 minus 16. That's equal to 80. So 3 is between 0 and 80. Therefore, by the intermediate value theorem, there is a C in my interval from 0 to 2 such that f of C is equal to 3. All right.